I had written this sheet for review one time, and the class said, "Could you post that?" So I scanned it and posted it. So now it's scanned and posted for whoever takes me. So these are the basic. There's 4 types of Chapter 6 problems. When I want you to convert X value to Z-scores, that's how you do it. You can draw your picture and see that your answer makes sense. Given a normal distribution and given a mean and a standard deviation, you can find the probability that X is between or less than or greater than with normal CDF. But if you're given an area, you use inverse norm, the area to the left. Z equals that. If you're looking for an X, then you need to convert to X. It's 2 steps, or you can do it in 1 step, the shortcut. If you're finding X, you have to put in the mean, the area to the left, the mean, and the standard deviation. And the last type was sampling distributions. They tell you you have a population with a mean and a standard deviation. If the population is normal, then N can be any size. But if the population is not normal, you have to have N greater than or equal to 30. You have to find your new standard deviation first, mark your curve off for that, and your mean stays in the same place, and you find your probability of a mean with this thing. And so this is posted in D2L, but it doesn't have what I wrote in purple. It just wrote in purple. So that's basically Chapter 6. I mean, it's important for the multiple choice to go to look through the notes and definitions and understand those. And then I have posted in D2L a Chapter 7 flow chart. Chapter 7 flow chart really tells you what we've been covering today, and last time was this. That we have, if we're doing a confidence interval on means and proportions, is sigma known? Is the population standard deviation known? Yes, then use Z interval. And no, use T interval. If it's a proportion, you're going to use 1 proportion Z interval in the calculator. And we haven't done this size. We haven't finished this yet. So this might be something handy for you to print out to help you too, this flow chart. My other classes really liked it. That's under the notes in Chapter 7, if you want to print that. So here's where we were. We had just done an example with birth weights with a mean, and we knew sigma because it said all birth weights, so that was sigma. So we didn't have to use these formulas, we used the interval. And then if we need to find E, we'd find it with upper minus lower over 2. And we found that, and then we asked which one was wider and why. So now we're going to do an example, the next example. These are all examples about mean, but you should always ask, is it a mean or a proportion? Because we're only doing means and proportions in this chapter. So, in a test for the effectiveness of garlic for lowering cholesterol, 49 subjects. So this is n equals 49. And we call the people that participate in an experiment subjects. Were treated with raw garlic. Cholesterol levels were measured before and after the treatment. The changes before minus after in their levels of LDL cholesterol in milligrams per DL had a mean of 0.4 and a standard deviation of 21. So, mean of 0.4 and the changes in their levels, what are we referring to? This sample of 49 people. So this is a sample mean, and this standard deviation, it doesn't say all, the standard deviation of all, and it doesn't say population standard deviation. So this is a sample standard deviation, so it's S. So what's the best point estimate of the population mean net change in LDL cholesterol after the raw garlic treatment? It's the only, a point estimate is a single point to estimate the population parameter we're interested in. We're trying to say something about mu, the population mean. We will never have the population mean in chapter 7. In chapter 6 we had population stuff. Here we won't. This is more, we're trying to estimate it. So the best point estimate for a population mean is always the sample mean, x bar. And so you just get it and you write that here. Don't write everything here because I'll think that you don't know what the point estimate is. So just write the point estimate. The best point estimate for mu is x bar. And then we're going to construct a 98% confidence interval. C is 98%. So, let's see. That was just, so the best point estimate after the raw garlic treatment, that's taken right from the problem. Okay, I'm gonna go back to this. We're gonna use our calculator instead of these formulas. There's formulas you could use, but let me show you the chapter 7 flow charts. It's a confidence interval on a mean, and we don't know sigma. We only know S. We will know a standard deviation. We'll either know S or sigma. So we only know S. So we do a T interval. So we have to do a T interval on our calculator. So you go into your calculator. I'll show you what the T interval's asking for. We go stat, arrow right to test, skip all these that say something test. Those are all chapter 8. Go down to number 8, T interval. So chapter 7 is the Z interval or T interval for means, or 1 proportion Z interval for proportions. That's what we're using. So it's a T interval. We choose T interval. And we don't have a list of data. If we had a list of data, we'd put it in list 1 first, and we'll have an example like that. And then we choose data. So we have statistics, so we leave it on. If this is highlighted, you leave it highlighted. If it wasn't highlighted, it looks like this, and you have to go back over here and highlight stats. Okay, so we've got stats is highlighted for this problem. So it's asking for X bar, it's asking for S, it's asking for N, and it's asking for the C level. And then we hit calculate. So for this problem, we had X bar is 0.4, S is 21, N was 49, our confidence level is 98, and then we'll hit calculate. And we can move this up so you guys in the back can see. 0.4, 21, 49, and 98. And then we hit enter on calculate. And it takes a little longer because it's doing more stuff. Oh, there it goes. Z interval came right back. This took a minute or something, or 30 seconds. All right, so here's the interval. You need to write it with the population parameter in the middle. And we usually round to like one more place than, don't put all the places down, but one more place than X bar, or maybe I'll tell you how much to round to, but. So we get the answer, and it's mu is less than, we have to put the population parameter in the middle with the right symbol, negative 6.82 and 7.62. I rounded to two places. That's my 98% confidence interval. So your calculator gives it to you in interval notation with parentheses. We're going to go to that one more place and X bar. Still put 5 places down. Hard to read. Okay, and then we're going to interpret our interval. And that was a statement where we said we are, and then the percent confident, 98% confident. That and then we look back at the problem. Mean net change in LDL cholesterol after raw garlic treatment. And you can shorten that, but you have to say it in terms of the problem. That the mean net change, I'm just going to shorten it into this, LDL cholesterol. I'm going to leave off after the raw garlic treatment, is between negative 6.82 and 7.62 milligrams per DL. You need the units. This is words. So don't just save a step and put this thing right here. Don't put this box right here with the symbol, because that's not words and it doesn't have, so you want it doesn't have the units. You want units here. For means, there's going to be units. For proportions, it's going to be percent. You want your units, and you don't just grab this and put it here and save a step. Okay? And that's, so we say we are blank percent confident, and then we write it in terms of the problem, and it is between, and we put the two limits. Okay? Any questions? All right, and we'll look back at the slideshow here. So So we interpret our confidence interval. And so on the slideshow, there's just an extra question that's not on your notes. So let's look at that. And you don't have to interpret your interval exactly like this. You can write it the way I did. But what does a confidence interval suggest about the effectiveness of garlic in reducing LDL cholesterol? Okay, it was a change in LDL cholesterol. So if zero's in the interval, it means there could have been no change in their cholesterol levels. So we're saying because the confidence interval limits contain the value of 0, it's very possible that the mean is equal to 0, suggesting the garlic treatment did not affect the LDL cholesterol levels. So it does not appear from the confidence interval that the garlic treatment is effective in lowering LDL cholesterol. This is just one study, and we try to use actual studies, but don't base whether you take garlic on this one study, this example. I happen to take garlic, I think, but no, I'm trying to remember if I take garlic anymore. I used to, anyway, take fish oil, I take all kinds of stuff. Anyway, don't base all that on that, but so it looks like it's not effective because 0 is in there, and it was a change in LDL levels. Now we're going to do an example where we have a list of data. And if you have a list of data, it can only be a mean. For proportions, and I'll write it on here, let's see. So we'll work this problem in a minute. So this chapter 7 flow chart, if you have a list of data, it's usually here. Unless there's a separate sentence that gives you sigma, you can only find, it's usually a list of sample data. We usually never have actually population data, so we usually have sample data. So so for data, unless there's a separate sentence that says the population standard deviation is, or the population of all such and such is known to be, then we only know S. And even though you can put that list in your calculator and do one variable stats, and the calculator will show an S and a sigma, if it's sample data, you're not supposed to use sigma. So for this example, in a sample of 7 cars, each car was tested for nitrogen oxide emissions in grams per mile, and the following results were obtained. And in order to work this problem, you have to assume the population is normally distributed. So I will usually write that on your problems. Some books do, some books don't. So we should have actually written that the population of nitrogen oxide emissions is approximately normally distributed. So because n is just 7, according to the last part of chapter 6, our x bar would not be approximately normal with just 7 unless the population is normally distributed. So what you do when you have a list of data and you know it's talking about means. So your first step, is it a mean or a proportion? It's a mean. you got to put your data in list 1. So you're going to go into list 1 and put that data in there. Stat, edit, clear out the list. 0.06, 0.11, whoops. Oh, I entered 2 periods. Stat, edit, 0.06, 0.11, 0.16, 0.15, 0.14, 0.08, and 0.15. So, we want to make the list of data pretty short because of how long it takes to type all these things in. But it would be good to have more data. So you double check, especially if it's a test, that you entered all that right. And I did. So second, quit. My data's in list 1. I don't have to do stat 1 variable statistics now. What I need to do is I need to skip to down to part B. Part B says construct a 98% confidence interval. So you can go, did it say anywhere in a separate sentence that the sigma or the population standard deviation was something? No, and this is a sample data, so we can only find X bar and S from this data because it's a sample. So we need to do a T interval, and we're going to start. We're going to start with part B because part B is going to give us the point estimate when we do that. So part B, we've got C is 98%. And so we're going to choose data. So stat, test, T interval, number 8, and you choose data. And if you put, does yours say list 1, and did you use list 1? If you didn't use list 1, then you press second, list 2, or whichever one you used. Frequency. Leave the frequency at 1. So let me write this down. You need data, and then it asks for a list. I just always use list 1, but you can press second, whatever list you use. Frequency. I'm not going to give you a frequency distribution like chapter 3, so you always leave it at 1, or I don't know if you guys that have that stat wizard, if it leaves it blank on that. Does anybody have the stat wizard on this? Okay, and then you put your C level, and you can either write 0.98 or 98, and then calculate. And that's how you find. There is a formula you can use. This is how you find your interval, and it's a mean, so you put the population mean in the middle with less than signs, the lower limit, and let's see, the data went to 2 places, so we'll go to 3 on this. 0.075 and 0.168. Okay, now look what else it tells me. It tells me X bar is this and S is that. So the point estimate, the calculator will give me that, or you could have done one variable statistics to find it, but X bar is 0.121. That's the point estimate for a mean. We don't need S, but it's there. Don't write S here. If you want to write what S is, you can write it up here, 0.0389, etc. But see, if we choose data and we have our data in the list, we don't have to even write that down. Did everybody get that interval? Okay, that's the answer to B. Interpret your interval. We are 98% confident. In math, we use the plural we on this stuff, like we're royalty, you know. I'm going to do the queen wave here. I'm not too good at it. We are 98% confident that, and then write this, and that's the population mean. Write it in terms of the problem. Its mean is full of nitrogen oxide emissions. Nitrogen oxide emissions is between 0.075 and 0.168 grams per mile. And that's how you write your statement, and then I have a fill in the blank activity. Under Nearpod. And that stuff, and here's what I put in the calculator. And we filled in all that. You don't have to write the word population, but never write the word sample. And I said all cars here, so you could write it slightly different. Oh, here's the fill in the blanks. Okay, so mine gives the answers. I guess it's because I'm showing names. Let's see. There we go. All right, the first blank is I think it's mean. drops it here. Okay. So did you get those? That's the correct answer. Margin of error, it doesn't, once you get done, it doesn't let you fix it. Okay, so that's, and the flow chart can help you with this stuff too, but really the formula sheet has the flow chart on it. Okay, we're going to go to the next thing, finding the sample size required. Okay, so to find the sample size required, we do need to use formulas. And these are the formulas. I'll write them down. If it's a proportion, we would solve that other formula for E for N algebraically, and this is what you get, but this is on your formula sheet. N equals P hat times Q hat times the critical value, I haven't explained what that is yet, divided by E, the margin of error, and that part squared. And you do need to know that Q hat is 1 minus P hat. And if your answer is a decimal, we always go up to the next whole number. It's because we're trying to keep E within some value. So, and the formula, these are for proportions. When we don't have an estimate of P hat, then the most conservative estimate is 0.5, and P hat times Q hat, if P hat is 0.5, is 0.25. So when we don't know a sample proportion at all, we can use N equals 0.25 times the critical value, which I'm going to explain, divided by E, the margin of error, squared. And we find this critical value from the confidence level, and the problem gives us E. So we can, from just two things, we can find a sample size. So if we want to do a study, if we're out in the working somewhere and want to do a study about cholesterol, for instance, you want to know how many people you should sample. What kind of sample size? Well, it depends on your error, and it depends on the confidence level. And I don't think I brought a formula sheet with me, so I'm going to go into D2L and print it out. Is it time? No, not quite time for a break. All right, I'm going to 1530. So this is where I have this formula sheet posted. And it has common critical values on it. So let's see. Might have it. You might have to hit show all newsletters, and I might have it on here. I haven't kept up with switching. Last day to drop is March 30th. There's applets demonstrating the central limit theorem. Oh, here's the normal distribution tables. down here, I had to click show all. It's also under content test reviews, I believe, test 3. Positive and negative z-scores. See, the positive one's what I want. You probably don't need the negative z-scores paper. But this one has common critical values at the bottom of it. So I'm going to hit print. Print. Math. Print. So you probably only need the positive one. And I have a picture in my of this, but that's where it is. I forgot to bring it with me, so common critical values. If you these are the common confidence levels, and these are the critical values. But let's talk about what a Z critical value is from the slideshow. Okay, so what if we want to collect sample data in order to estimate some population proportion or population mean? You need to know how many sample items must be obtained, or the sample size. So here's the sample size for P, and that's what I just wrote down. And here's a critical value. So this is the definition of a critical value. So what is this Z subscript alpha over 2? It's shorthand for getting a Z-score when you know an area. It's alpha over 2 because we want the area to be split on the two ends of the normal curve. The center of the curve is the confidence level, which equals 1 minus alpha, and the two tails is alpha, so you split it in half because it's symmetrical. So this area is alpha over 2, and this is alpha over 2. And if you had converted your x values to z-scores, you'll have z equals 0 in the middle, and this is your critical value. And that's the notation. You don't divide it, you don't divide z by 2 or anything. It's z subscript alpha over 2. This area right here. I mean, that is not an area. Alpha over 2 is an area. Z alpha over 2 is a number on the horizontal axis. So the definition, a critical value is the number on the borderline separating sample statistics that are likely to occur from those that are unlikely to occur. So let's fill in our notes. So a critical value is a number, it's on the horizontal axis. And it separates numbers that are likely to occur from those that are unlikely. And we denote it if it's the standard normal curve with a z subscript alpha over 2. Where alpha over 2 is the area in the right tail of the standard normal distribution. Okay, so we're going to find some critical values, and you can find the critical value using the absolute value of inverse norm of alpha over 2. So we're going to find that critical value. Here's an example. it says it's a 78% confidence interval. So draw the picture. Then we have 78% in the center. This is our z subscript alpha over 2. So how do we find this z? This will be negative z alpha over 2 because z's are symmetrical, and negative to the left of the mean, positive to the right of the mean. So we need to find the area in the two tails. That's alpha's 1 minus c, 1 minus 0.78 is 0.22. And then we divide that by 2. 0.22 divided by 2 is 0.11. So we have 0.11 here, and we have 0.11 here. So our critical value, and there are actually 2 critical values for confidence interval, but there are always 2. C is always the central area. So since there are always 2, we'll just talk about the positive one and know that the negative one's there too. So in my stat lab, if it asks for critical value for confidence interval, this was the positive one. So you can either add up these areas and find that, z alpha over 2 is 0.89, inverse norm of 0.89, but that's harder than just taking the absolute value of inverse norm of 0.11. It's going to be the positive number. So we do it either way, but you could always, if you get messed up with forget to use the absolute value, then maybe you're going to want to add up the areas. Inverse norm requires the area to the left, but we can use the fact that z is symmetrical and take the absolute value. Inverse norm, so we go into our calculator. This is chapter 6 stuff in chapter 7. So number 3, inverse norm of 0.11, and then we know we need the positive value. And we usually round z to 2 places, unless it's one of those common critical values where on the table they've rounded to 3. So this is going to be positive 1.23. Any questions? We're going to do another one. Oh, you guys get to do it. And I step you through it. So there's a draw. But do you have questions about this first? There's the draw. Yeah. Oh, okay. Yes. You have a stat wizard on it? Okay. Well, if it's z, you leave the standard deviation at 1. Z is the standard normal curve that has a mean of 0 and a standard deviation of 1. So, or you can get rid of this if you want to plus minus. This is actually probably what you need. So it's asking for the area to the left. You're just supposed to put 0.11 there, and then go down to 8. This is z. We're talking about z goes up 0 and 1. And now it looks the same. And then you take the absolute value. Okay? 2, 3. So z equals z alpha over 2. Z subscript alpha over 2. So on this next problem to draw it, I gave you the steps to help step you through it. You won't get the steps on the test, but up? Yeah. Oh, you did it. That's quick. You did this. It's a draw it.
Yeah.
Looks like a slide. You can write right on it. Yeah, you can either write or you can use the text box. Do the little delete there. If you want to put the text box, you can slide it instead. You can do that. And then if there's Greek letters or something, you'll have to do write out alpha. Yeah, it's kind of hard to write. Oh, people are already showing up. I could get it off of that screen so you can see everybody. But you can use text boxes too. Some of you do that. So I wrote a few things down on my notes here. All confidence intervals are two-tailed. Alpha equals the level of significance equals the area in the two tails. And in terms of, for the 90% confidence interval, this is one of the common critical values. They want you to round to 3 places, but it's because you will actually not do it by hand like you're doing right now, or you've done. You'll actually look it up. I'll give you this positive z-scores paper, and you look it up at the bottom of this paper. A 90% confidence interval, you use a critical value of 1.645. So you won't actually do inverse norm to find a 90% or 95 or 99. You'll use these values. And these, when I ask you to do problems, I'll ask you at these levels. These are the common critical values and confidence levels. And so you'll just, the skill of finding a critical value is just like one question that's 2 points on the test. So, but, now some people like to always use inverse norm to find them, but. So that's the critical value. We'll go back. Are we done with this? I think most people are done. We may be waiting drawings from last time, so I'm just going to click. As soon as I click here, you can't. Has everybody hit submit that wanted to? Oh, I love yours. Yeah. Did you give up?
No.
Oh, you were having fun with the. So as soon as I hit share, oh, I guess I don't have to hit share. So alpha is 0.10, alpha over 2 is 0.05, and okay, we did need to take the absolute value. So the critical value is 1.645 without the minus sign. But that was very good. And I didn't tell you to round to 3 places, so a lot of people just put 1.64 because the next number was what, 4 and then 9. So that's correct too. But from now on, this is a common critical value. We won't be doing this for this confidence level. So good job on that. And so these are the common critical values. So you won't be doing inverse norm to find these. And for these two, you do need to use all three places. And I will give you, so either write those down or print out this paper, but I will give this to you on the test, this paper. But those are the common critical values that you're going to be using. And then, you know, if you notice, we did a 98% confidence interval today. Well, that's because our calculator lets you put in any number you want. So it's only, I could ask you for a 98, but I couldn't ask you to find the sample size for a 98 because well, I could, but won't. Because you'd have to find a critical value for 98, and it's not listed in the common ones. But all right, so you did the DROT, and if you want to write down this stuff, we're going to take a little break and finish this up. But I did write, I think I told you this, but I'm not sure if I wrote it down. All confidence intervals are two-tailed. Alpha is the level of significance. It's the area and the two tails. So I'll work that problem. If this is 0.90, this is our z alpha over 2. Alpha is 1 minus c, 1 minus 0.90, 0.10. Alpha over 2 is 0.10 divided by 2, 0.05. So z alpha over 2 equals the absolute value of inverse norm of 0.05, and that's 1.645. And I didn't tell you to go to 3 places. Basically, when the third digit is like a 5, they go to 3 places. And then we're going to actually find sample sizes for proportions, the sample sizes for mean. We've got a formula. All right, we'll keep going. We're almost done. 2 more pages, I think. 2 more pages. Okay, so these are examples. This is an example. Do you see the word mean anywhere in this problem? No, you see the word proportion and you see percentage. This is finding the sample size for a confidence interval on a proportion. So we're going to use these, we're going to use the formulas from the previous page. And it says how many adults must be surveyed in order to be 95% confident. So C is 95%. From our common critical values, or we look on our positive z-scores paper at the bottom, these are the confidence levels. These are the common critical values over here. For 95%, we use 1.96. So our for 95%, z alpha over 2 is 1.96. We don't divide the 1.96 in half or anything. That's just a notation for the symbol to say that's the critical value. Okay, so how many adults must be surveyed? So we're looking for a sample size to be 95% confident that the sample percentage is in error by no more than 3 percentage points. The 3%, which we write as a decimal, is our E. But it said no more than, so we need to keep E less than or equal to that, really. So that's why if we get any decimal, we go up to the next whole number. So if your answer is a decimal, you go up to the next whole number. That's why. So it's not regular rules of rounding here. So assume nothing is known about the percentage of U.S. adults who use the internet. So this is saying we do not know p hat. So our formula when we don't know p hat is n equals 0.25 times the critical value divided by E, and that part is squared. Since it said E was a percentage, we had to convert it to a decimal. So that's 0.25 times 0.03, no, I'm sorry, 1.96 goes in the top, divided by 0.03 squared. Now make sure you're only squaring this part and not the 0.25. The 0.25 is not being squared. You can put it in your calculator like this. Make sure you can get the right answers. 0.25 times parentheses 1.96 divided by 0.03, close the parentheses. Don't hit enter and square it, because that'll be squaring the 0.25. You need to hit x squared here. Can you see that? Can you see my calculator? So that's what you need to put in your calculator. You can put it exactly like that. It'll do the right order of operation. And you get 1067.111. So 1067.11. You got a decimal, so you need to go up to the next whole number. You can't sample 1067.1. So you go up to 68, because if you went down to 67, E would not be very much bigger than 3%, but it'd be bigger than 3%. So no more than 3%. So we had to go up. We got a decimal. Now if we get a whole number, we leave it. Don't go up to the next number. All these confusing things. You got it? All right. And then from a previous study, oh, well, I forgot. So here's my work, and I went up to 1068. Now we're going to assume that from a previous study, you know that 73% of adults use the internet. So now this is your p hat. Everything else is the same. It's still a 95% confidence level. The critical value is still 1.96. The margin of error is still 0.03. Now we got a p hat. We're going to use the formula n equals p hat times q hat times the critical value divided by E squared. P hat is 73%, change that to a decimal, and Q hat is 1 minus P hat is 0.27. 1 minus 0.73 is 0.27. So this is 0.73 times 0.27 times 1.96 divided by 0.03, and that's squared. So this stuff stayed the same, but we have a difference out here. If we multiply those, and I'll do it, you can see that that's more than 0.25. So 0.73 times 0.27, or it's different, it's less than 0.25. Okay, sorry, less than 0.25. Multiply that by 1.96 divided by 0.03, close the parentheses, and square just that part. So it's going to square this before it multiplies. And we get 841.3. So we go up, so n is 842. So to keep your error within 3%, you would have to sample 842 adults. And it should be a random sample, or a cluster, or stratified, which is also partly random. Okay, so that's how do you find sample size for proportions? Well, how do you find sample size for population means? Sample size is small n. The formula, we will always be given sigma on these. The formula is they've just solved E for a mean for n, but we give you this on the formula sheet. C alpha over 2 times sigma divided by E squared. Don't forget to square it. And then if you get a decimal, you always go up. So that's what the arrow means. So that's the formula. So we're going to do an example for that. Here, okay, that was the last one. It's the same formula for the critical value. If we need to find it, you can find that by taking alpha divided by 2 inverse norm of that, the absolute value. Alpha is 1 minus C. So here's the example. So if you want to estimate the mean IQ score for a population of statistics students, how many statistics students must be randomly selected? So that's asking for sample size. If we want to be 90% confident, C is 90%. So according to our common critical values, for 90%, we're going to use 1.645. Z alpha over 2, 1.645. And we want the sample mean to be within 3 IQ points. It's not a percent, so E is actually 3 here. And assume from previous studies that the standard deviation of all statistics students, whoops, you guys aren't professional pilots, are you? I changed the problem, forgot to change that. Is 15. Unless you guys are you guys all professional pilots? You know, if you're a statistics student, it means you have to be a professional pilot, right? I mean, no. No. is 15. So it's telling you that sigma is 15, the standard deviation of the mean of all statistics students. Okay. So we're going to use this formula. N equals the critical value, 1.645 for 90%, and then times sigma, which is 15. And then we're dividing by 3, not by 0.03, and we're squaring that. So if E is a percent, you change it to a decimal, but in means E is not usually percent. So it's a number, you leave it at that number, don't change it back to a decimal, because that did not say percent. It said within 3 IQ points. Didn't say within 3%. So it's a 3, and you'll get the wrong answer if you use 0.03. So be careful about what you're dividing by there. Type this in your calculator. And some people have the hardest time typing this stuff in their calculator and getting the right answer. So practice it. Make sure you can put it in your calculator and get the right answer. Times 15 divided by 3. Close it and square it. And use the right formula. Sometimes people try to use the proportion formula for mean. Okay? And that is 67.6 something. You go up, N is 68. Because we had to keep it within 3 IQ points. So if you use 67, it's not going to be within 3. All right. So we found critical values for Z, and we found sample size for proportions and means. The last thing we're doing is a T critical value. The student T distribution, this information was on a previous page, wasn't it? But, oh, I think it was in chapter 6 notes, actually. The proportion. No, I have it here. I mean, I had this stuff about the T distribution. What if I ask you to find the critical value for a T distribution when we only know S? You can find this, and it's another table. So, and I have part of the table printed on your notes for you. So, where is it in here? It's under content. I didn't see it in the, so content, test, review material, test 3, T-scores. Here's your T-scores. We hit download. And print. I'm going to print it. Okay, so I don't think you need the negative Z-scores because you want to have the positive one printed out. And this T-score one, this is for finding critical values of T. So this is a review about the T distribution. The student T distribution is bell-shaped and symmetric with a mean at 0, just like the Z distribution, except sigma is not exactly 1 for a T. Degrees of freedom is defined as n minus 1 T alpha over 2 is the critical value. So T alpha over 2 is the critical value for a T distribution. When we don't know, or when we only know S. We will know a standard deviation for a mean, but sometimes we'll only know the sample standard deviation. So we'll use either the table or your 84 calculator. Your 83 doesn't do this. If you have an 84, let's see, do I have a, oh, I have it on the next page, that formula, okay. So this is a T distribution. It's for means. It's a critical value. T alpha over 2 is the critical value for T distributions. We also have critical values of T, and again, all confidence intervals are two-tailed. I wrote that before. And we only write down the positive critical value. Since we know there's a positive and a negative, but for confidence intervals we know they're always two-tailed, so we're saving some writing and we write down just the positive one. These are our steps. We still find alpha by taking 1 minus c, and then we find our degrees of freedom by taking n minus 1. And then if you have a TI-84, you can use inverse T under distributions to find that, but I don't. Well, maybe I do have it on mine, but not on the computer. If you don't have an 84, you can use this table, which I'll give you with the test. And for confidence intervals, they're always two-tailed, so we won't be doing this stuff until chapter 8. This is chapter 7. We have the area and two tails, that's alpha. We have degrees of freedom over here, that's degrees of freedom equals n minus 1. So we're going to do an example with a T distribution to find the critical value. So that's another skill. Yes?
So on the TI-84, when you do the IMD,
Yeah.
for the area,
Yeah, I'm going to do an example. You're getting a little ahead. Let's do an example.
I'm asking, how do you, like the TF on the example 10 is,
No, degrees of free. Okay, let's do this example together. Find the critical value for a 95% confidence interval. So we have 95% in the middle. So our alpha is 1 minus 0.95 is 0.05, and our alpha over 2, there's a typo there, is 0.05 divided by 2, 0.025. So if you're using your calculator, your T alpha over 2 is the absolute value of inverse T of, this is negative T alpha over 2. So we're using, if you want to put in the 0.025, this is also symmetrical, comma, and then 9. Degrees of freedom is 9. It's 10 minus 1. Sample size was degrees of freedom is n minus 1 is 10 minus 1, 9. And you take the absolute value. I can't show you. Or you look up on this table The area in the two tails is 0.05. Degrees of freedom is 9. And this is your critical value. You should get, when you take the absolute value, you should get 2.262. Now I can see if my calculator actually has that on it. Or you could have put in 0.95 plus 0.025 for the area. So this calculator here, I think, second distributions, it has an inverse T. If I choose that, not all your calculators have this, 0.025, comma, 9, and I get negative. I have to take the absolute value and make that positive, and I get the same answer. I don't know if you can see that. No, not really. What? No. There. But all your calculators don't have that. So if you're going to use your calculator, you have an extra step. You have to divide alpha by 2, and you should draw the picture. If you're going to use the table, which you'll have, and you can print out to practice it, this is only worth 2 points on the test anyway. Okay, not a big thing. It's on the quiz too, Chapter 7 quiz. Opens up today, closes Tuesday. So on the table, you're always looking just for alpha, and the area in two tails is alpha. You don't have to divide it by 2. Look at 0.05, go down to degrees of freedom, and that's your critical value. So we found it on the table pretty easily. I think actually the calculator might be more work. I think it might be easier to use the table than the calculator. And so I think that's, let's see if, and so I did that example, I drew the picture. It looks just like the Z, except it says T alpha over 2 here. I put the picture, there we go. That's how you get it. Degrees of freedom is 9, area 2 tails. You also could use area in 1 tail as 0.025, see? If you find area in 1 tail, use that. Same. Okay, and that's it. Any questions? Your Chapter 7 worksheets due next time. There's an extra worksheet with answers posted there to help you. You have to determine if you're doing a mean or a proportion. I think that this flow chart might help you, or the formula sheet. And we're done with Chapter 7. We'll review but remember to do the D2L Chapter 7 quiz. Thanks for coming to class, guys. 1, 2, 3, 4, 5, 6, 7. We had like 26 people in the class. I don't know if it has staples in it. And I don't know. Oh yeah, it does have staples in it. I do have warm-up posted on D2L for Chapter 6 and 7 as answers. So you could also
She actually put on.
She did?
She is on now. So
She said?
she said that there's like something going on with she was my face and accomplished because of it. And that the wish out and she's getting them all the
Oh, she is
So
having
there
some.
may be, yeah, so it may be like something major happening with that. She's like, I have to.
Oh, well, somebody else told me yesterday that her stats Peter's been on her. Well, you can go to the learning center.
No, I know, I was planning on doing that.
Yeah, the learning center's good. Usually I do some of the warm-ups, but figure, I don't know. Unless you, I give you a lot of information, don't you?
Yeah,
Yeah, so, the warm-ups are posted if you wanna do them, but if you get them from the notes. Yeah, the warm-up, what would happen is we spend maybe an hour on the warm-up. And the people in this class, everybody else before. And I don't know, we just haven't had, the people that started missing class, they're just totally just not coming back, so. Mm-hmm. Oh. There's my Quizlets too, you know. We'll use those, but. Did we decide that